This is Professor Derf Seitz, Reasoning via Contradiction. Strategy. To determine whether something is true, a strategy that uses contradiction proceeds as follows. Assume that this statement is false. Find logical implications that would result if this statement is false. If you reach a contradiction of known facts, then the statement cannot be false and therefore must be true. If no contradiction is encountered, you have not proved anything, because there may yet be a contradiction that your exploration did not encounter or uncover. Some background information for examples that will be shown. A line is parallel to itself. So we don't really want to spend much time on that. That's self-evident. Two different lines are parallel if and only if they have no point in common. It's a definition. Different lines are parallel if they have no point in common. That means they don't intersect. And since it's if and only if, the other way is also true. They have no common point and they're parallel. We're talking about different lines here. You don't want to get bogged down with the exception case of the same line comparing it to itself. Example 1. Prove that if two different lines have the same slope, then they are parallel. Here's a picture. Two different lines, slopes M1 and M2. Lines are labeled L1 and L2. And we want to show that if the slopes are equal, then the lines are parallel. That's the symbol for parallel lines. So if the slopes are equal, we want to show parallel lines. Let L1 and L2 be the two lines with common slope M, because the slopes are equal, there can be called one variable, and with y-intercepts B1 not equal to B2 respectively. Because they're different lines, their y-intercepts are not going to be the same because they have the same slope. They're different lines. We start out here with our strategy. Assume the two lines are not parallel. Let's remember what we're doing here. If we go back, it says we want to prove that they are parallel. So we assume that they're not parallel. This implies they have a point in common, say x1, y1. Compute the slope of L1 using its 2 points, this common point x1, y1, and its y-intercept 0, b1. Slope, rise over run, y1 minus b1 over x1 minus 0. That's y1 minus b1 over x1. And similarly, compute the slope of L2 using 0, b2 and the same common point x1, y1. And we get slope M, again, is at this time y1 minus b2 over x1. Since these are different lines with the same slope, since b1 is not the same as b2, these two results would imply that M is not equal to M because these are different. Everything's the same except b1 and b2, and that would be a contradiction. Therefore, the two lines must be parallel. Example 2. Prove that if two different lines are parallel, then they have the same slope. This time we start with the given that the lines are parallel, and we want to prove they have the same slope. Let L1, L2 be the two parallel lines with y-intercepts b1 not equal to b2 respectively. Assume their slopes are not equal. let M1 not equal to M2 represent their slopes. Write the equations of the lines in slope-intercept form. For L1, y is M1x plus B1, and for L2, y is M2x plus B2. Solve this system by subtracting the second equation from the first. Y minus y is 0. Here we have M1x plus B1 minus this binomial, so we put in parentheses minus M2x plus B2. Distribute the minus sign. We have M1x plus B1, then minus M2x and minus B2. Take the common x and factor it out of these two terms here, and we have x times M1 minus M2 plus B1 minus B2. And then we'll add B2. Remember, we got 0 on the left. Add B2 and subtract B1, and then divide both sides by M1 minus M2 to get x is B2 minus B1 divided by M1 minus M2. Since M1 is not equal to M2 by our assumption, that implies that M1 minus M2 is not 0, which implies that this is a valid value and the system has a solution, which implies the lines have a point in common, which is a contradiction because these two lines are different parallel lines. Different parallel lines don't have a point in common, so we've reached a contradiction. Therefore, their slopes must be equal. So we can see here that contradiction, that strategy for showing things, is a productive and useful strategy to know about and make use of.